Hello, my name is Shailendra Chaudhary, and in this video I'll explain pod disruption budget in Azure Kubernetes cluster. So what is disruption? Any event or incident where the normal running of an application is impacted. There are two different reasons for the disruption. One is involuntary disruptions, where you don't have the control over the event. That can be hardware failure, kernel panic, deletion of a node in a node pool. And the second one is voluntary disruptions, which are triggered or initiated by you. And these include like cluster upgrades, you have made the changes in the configuration of the deployment template itself, or you have accidentally deleted a pod. So these are the reasons for most of the disruptions. And now I'll talk about how to minimize the voluntary disruptions. Using the pod disruption budget, you can limit the number of concurrent voluntary disruptions. For example, if you are upgrading a cluster, then the kube scheduler will not reboot the node until the specified number of pods in the pod disruption budget are successfully running on the other node of the cluster. So the pod disruption budget can be defined in two ways. One is minimum available, another one is maximum unavailable. In the minimum available, as the name suggests, the specified number of pods must be available in case of a disruption. However, in the case of maximum unavailable, the specified number of the pods can be unavailable during a disruption. And while defining the pod disruption budget, either maximum unavailable or minimum available can be used in a single configuration. And the values of the minimum available and the maximum unavailable can be expressed in integers as well as the percentage. So you can define a specific number. For example, if you have set up the number as 10, that means 10 pods must always be running even during a disruption. However, if you set up a percentage, means 50%, that means 50% of the pods must always be running, which will be calculated as 5. And there is an important thing to note that while creating the pod disruption budget, label selector has to be defined, because the pod disruption budget has to understand on which specific pod configuration is this going to apply on. So as you can see on your screen, I've defined both the ways of pod disruption budget, where the minimum available it's 3, other one is maximum unavailable it's 2. If we have 5 running pods, that means it will be same. Here we have defined at least 3 pods should be running. That means at least 3 pods should be running because 2 can be unavailable. And for the selector, we have to match the labels of the pod. In this case, it's app and Nginx frontend. So once the pod disruption budget is defined and the label is correctly selected, then the kube scheduler will take care of all the voluntary disruptions. Let's check this in demo. So I'm going to use the same AKS demo cluster which I have been using in all the previous videos. If we'll go to the node pools, there are 2 node pools. One is system pool with 1 node and a node pool which is a user node pool which also has 1 node. So if we'll go to the nodes, there are only 2 nodes. One is for the node pool, one is for the system pool. So in this demo, I'll take 2 scenarios. In one scenario, I'll not define the pod disruption policy, and in the another one, I'll define the pod disruption policy and see how it changes. So let's check the number of nodes in the command line. So there are 2 nodes. And using the command line, I'm creating a deployment, which is Nginx deployment, and it's using the Nginx image. So let's run this. By default, if we'll create a deployment using the kubectl command, then only 1 pod should be running. So let's check. So as you can see, only 1 pod is running and it's running on the node pool. Because there is only 1 node, so it's running on the node pool node. Let's scale the deployment to 5. Using the scale command, I'll scale the deployment to 5 and it will create the 5 replicas of the same pod. So let's check the pod. As you can see, all are running on the same node. So all the pods are running now. Just for this scenario, if I'm upgrading this node pool, then I have to drain this node so that none of the pods should be running on it. And once I'll do it, all the pods will be evicted. But in this case, system pool node has the taint defined. As you can see, I'll go to the node pool, system pool node, and it has the taint defined. That means none of the pod will be moved on this node itself. So let's check. kubectl drain node name -- ignore daemon sets. So we are ignoring the daemon sets here. Let's train it. First it's cordon. Cordon means no new pods can be scheduled on this. So let's check. So all the pods are pending now because the pods are evicted, but they don't have any other node to run. So they are in the pending state, which means if someone by mistake drain this node, then this will be a disaster for this application because now application is not running. None of the pod is running. Let's uncordon this node. Now you'll see all the pods will automatically be scheduled on that. Now they have started running on the AKS node pool. Now all the pods are creating. So in the first scenario, if by mistake someone ran the drain command on the node, then all the pods will be evicted, whether there is another node available to schedule the pods or not. To overcome this problem, I'll use the pod disruption budget. Let's create the configuration. So in this case, the API version is policy v beta 1, kind is pod disruption budget, name is demo pod disruption budget 1, minimum available 3, and matching label is app nginx. Let's check the label whether it's correct. kubectl get pods -- show labels, and app is equal to nginx is the label on it. So let's create this pod disruption budget. So the pod disruption budget is created. Now let's check. As you can see, minimum available is 3 and allowed disruptions are 2 because there are 5 pods running right now. So let's again drain the node and see whether it will evict all the pods or not. So I'm draining the node again. So it's evicting, but it's throwing error for 3 because 3 should be minimum available. Let's check the status in another shell. So you can see the 2 pods were terminated and now they are in pending because they don't have any other node to schedule on. And the other 3 are still running. So that means if the pod disruption budget is defined, then the application will still be running if there is a voluntary disruption. So in this case, nginx application will keep on running. As you can see, it's throwing an error that it can't evict the pod because of the pod disruption budget. Let's cancel this and uncordon the node. So now all the pods should be running again. As you can see, the container is creating, others are running. Let's delete this pod disruption budget and define the pod disruption budget again in another way, which is maximum unavailable. kubectl delete pod disruption budget, and it's deleted now. Let's create another one. As you can see, I've changed the name to 2 and maximum unavailable is 3. That means 2 pods must be running in case of disruption. And label is app nginx. So let's save it and apply. It's applied now. Let's check. So in this case, maximum unavailable is 3 and allowed disruption is 3. Let's drain the node again. So it's evicting the pods, but now it's throwing an error for 2 pods because out of the 5 pods, now 3 can be unavailable as we have defined in the configuration. So it's throwing error for the 2 pods. And if we'll go to another shell and check the status of pods, then we can see 3 are in pending state, however 2 are still running. That means application is still running, though the number of instances of the application are impacted, but the whole application isn't down in this case. However, as you can see in the first scenario, all the pods were in the pending state and they all were evicted. So using the pod disruption budget, we can make sure that the application is not impacted by any voluntary disruptions. That is all for this video. I hope you liked it. Please like and subscribe. Thank you.